My name is Alan Folmsby, and I will be telling you about 4 new laws of nature, and specifically they're about atoms. Now this is from a theory I started in May of 2017, and it's been improving up until last week. Now the first law, cubic stacks of nucleons are in most elements. Number 2, the protons make lines of protons outside the cube. 2 protons are in the cubes of elements that are light, like carbon through manganese. Then there's a transition to the heavier elements like iron, which have 8 protons in the cube. Now, most chemical bonds start at the ends of proton lines. So here's some photographs of the cube over here on the left. And also we can see a cube up here in a 3-dimensional model. And iron nucleus here has the cube in the middle of it. Now the iron has little pyramids on the 6 faces of the cube. Now every cube has 6 faces. So there's 6 pyramids on all the heavy elements after boron. Now I will repeat the 4 laws of nature that I've introduced. Number 1, there's a cubic stack of nucleons in the core. Nucleons are protons and neutrons. Carbon has a 2 by 2 by 2 cube, and there's a transition then, starting at iron, where the cube is a 3 by 3 by 3 arrangement, like over here. So there is an isotropic repulsion of protons away from protons in the cube. Therefore, the outside of the nucleus is not cubic, it is a hexagonal close pack. And that assures that nuclear shapes will last for billions of years, even trillions. And this area of mathematics is called finite crystallography. Second law, protons make lines of protons. Now this is very important, so remember this one. Outside the core, protons make lines of protons, as you see in iron. And the lines can sometimes make rings, and a current can flow in the ring of protons. Now what kind of current is it? That's for next year. So now, because of the lines of protons, all 118 chemical elements have a valence of 8 or less. That's because each line has 2 ends. And the ends are where the bonds start. So, the third law is that 2 protons are in the core of elements from carbon through manganese. And the standard chemistry, of course, talks about 2 electrons in the s orbital. And see how it matches? 2 protons in the core of light elements, 2 electrons in the core of light elements, because they are connected to each other. And the fourth law is very important for chemistry, that bonds start at the ends of proton lines. So for rings, the ends are the most prominent protons, since there's no end to a ring. Now, long lines have 2 ends, and they could have up to 30 protons in line. Like, say, iron has 12 protons in line in a ring. Here's my contact information. And the theory is called the Static Nucleus Theory of the face-armored cubic lattice. I have a book and a telephone and more pictures. Like I was saying, bonds start at the end of proton lines, like here. See, there's the end, and here's right before the end, and the bond comes out the end like this, like the needle. And the water molecule makes 2 bonds with oxygen, and the angle is arc cosine of -1/4, which is exactly matching the experimental value. And also the double helix of proton lines are similar to the double helix in important molecules. Here are some more elements. Here is neodymium with its long proton lines of 24 protons in a ring. And 18 protons in a ring for neodymium, 12 for iron, and there's boron. And I'm following the same rules for boron as I did for iron. Protons make lines of protons. And I was also surprised to promote this. Now, I want you to look at my new theory of ferromagnetism using a confluence of 24 lines of flux through the center of the iron nucleus. And I'll show you that picture at another time. Now I'm going to be finishing up with uranium. And this one we see at the top here is the uranium-235 nucleus, white protons and black neutrons. The exterior surface is all hexagonal close pack for good survivability over the eons. Now, there's 6 pyramids around the cube. There's the cube. And there's one big pyramid on the right with 159 total of the cube in one pyramid. Now on the left, we see there's 5 pyramids that sit on top of the cube. And this matches what is shown on the data. 75, 159, 75 in the 5 pyramids, 159 in one pyramid and one cube. And the precision of this theory is excellent. The end.